All right, gang, here we are. We're working on Raven, the long-term chatbot, cognitive architecture, et cetera, et cetera. So I guess we'll do a quick recap of where we left off. So where we left off was here. Let me open it this way. This will be a little bit better. Long-term chatbot. Okay, so here we go. So we've got some chat logs here where I speak. Whoops, go away. Where I speak, it records the original message, the speaker, the user, the timestamp, and I give it a UUID. And so then when we go to recall these messages, we recompose them. I deleted all of it. Son of a gun. Here, let's go ahead and open this then. So what I do is I reconstitute all the messages. So we get the user input, we save it, we vectorize it. Then we load the conversation. So we load everything that has happened. So in our load conversation, we go for a list in this, blah, blah, blah. We load the JSON that's there, and then we send it back sorted by timestamp. Okay, great, that's fine. So then with the memories, we fetch the most recent memories based on the current conversation. And then we take notes, and then we get the most recent ones, and then we generate a response. So summarize memories. This says like, okay, so we handed a block, and then we take notes about those most recent memories, and then we do this recent chunk, which is just the four most recent one, and we reconstitute that in our prompt file, which is prompt response. And so we put notes. So this is relevant from all of our previous conversations. And then we do, here's the most recent ones, and then we generate an output. Okay, so by popular demand, there's two primary things that y'all want to see. One is external sources, and two is long-term memories. There's a lot that we can do with long-term memories. So last time I took a couple of notes about let's do memory chunking. Let's do fetch declarative memories, such as external sources. And I think there was another to-do. Pick memories that are temporally nearby the most recent relevant memories. Okay, so that's all fine. But first, I realized there's something that we can add when we reconstitute these memories. So one thing that we can do is we can add in, so like when we summarize it, right, we put the speaker and the message back in. But another thing we can do is we can add in a timestamp that is plain English readable right at the beginning of the message. And since we have a Unix epoch timestamp here, we can reconstitute this pretty easily using a function. So I actually just had ChatGPT write the function for me, and it's super, super simple, super straightforward. So what we'll do is we'll just copy in this, and I'll show you what it does in just a second. So first we will come down to here. And I'll rename it to timestamp to date time. Okay, so and all this does is it uses the datetime module. It says datetime from timestamp. So we pass it in a Unix timestamp, and then we format the string. And the format that I wanted was for it to look like day, month, day of the month, year, and then the time. So this is just plain English readable, so that Raven will be able to read it. Because Raven could theoretically read a Unix timestamp, but unless the underlying model has been trained to translate a Unix timestamp, it's not going to make any sense. Whereas if we give it in plain English, then it'll make a little bit more sense. So I think what we're going to do is from here on out, when we go to save something, we'll just add the timestamp right here. because all memories, because here's the thing, if you want Raven to be aware of something, it has to end up in the nexus somehow. Now technically all this information is in the nexus, right? Because chat logs, this is Raven's core memory. And we're going to add more to this in just a minute. But first I want to go ahead and just add a clear text date timestamp. So where we do that is going to be here. So basically we need to add this to the message. So let's do timestamp equals time, not Tim, time. And then we will add, let's see, the time string equals timestamp to date time timestamp. Right, and so this gives us our string. And then we can do, actually, let's just go ahead and add it here as well. So we'll do time string, and we'll do time string, just so that it's there, it's saved. But then we'll also add it. I think I want to add the speaker and the time to the message so that it's all saved. So then we'll say message equals, so we'll do % for the speaker, and then another %. So the %s that's a placeholder for a string. So %string for the time, and then we'll do a dash, and then we'll do the original message. So then we'll do, so this will be user, and then we'll do time string, and then we'll do the original message. Yeah, so then we'll do this. So then we'll do A. And that should be good. And so then when we save the message, it'll actually be here. Yep, so that's good. So that's good. Let's go ahead and and then for time, we want to update time as well. So we're not declaring time multiple times. So timestamp will be that, and then timestamp. So we reuse that variable. So basically, we declare timestamp once, and so everything is going to say it happened at exactly this moment. And in fact, we should do timestamp immediately before, because this takes some time, right? Vector takes a moment to run, and so we don't want to record the timestamp as happening after the embedding happened. We want to know when it happened as soon as the user hit enter. And so that is how we're going to do that. Okay, so now let's do the same thing. So we'll come down here, and we'll just copy some of this. So timestamp equals here. So we'll get Raven's response timestamp as soon as Raven is done generating it, because we want to know exactly when Raven said, aha, I am ready to speak. And then we'll do time string and message. You can do that immediately after. And in this case, this is going to be Raven, and instead of that, it'll be output. And then we need to add, so we'll do timestamp here, and message will be message. And then we're also going to add time string after UUID. Starting at the comma. So we'll do this. Okay, I think that's correctly formatted. Okay, so now all this information is going to be stored in there. So, because rather than just recombining user and date times, let's just save it once and save it correctly. So that way each message will be complete unto itself. It will have who said it and when. So that's a tremendous amount of context, because who said it and when is a huge component of our memories, right? We don't. If someone says, like, do not what you can do for your country, right? That memory is intrinsically tied to JFK saying that, right? And you probably remember the first time you heard it. Anyways, I'm going to close my door so that we don't get any disruptions. I'll be right back. Okay, so we're going to, this is all fine. So I'm going to add some more memories. I'm gonna have a conversation with Raven, and then what we're gonna do after this is we're gonna have a dream sequence, and I think we're also we're gonna figure out how to save these summaries, because every time we perform cognitive labor, every time we take these notes, we should save them. So we're gonna have a notes directory over here. And this is actually very similar to how human brains work, which is, what I mean by that is every time you recall something, your brain has to reconcile a lot of stuff. And so you might have heard this term cognitive dissonance. Cognitive dissonance is the sensation that we get when when our brain recognizes, oh wait, hold on, we're holding conflicting ideas or conflicting informations. We have to reconcile it. And the reason that cognitive dissonance doesn't happen all the time is because not everything is always in working memory. So when Raven recalls stuff, we want Raven to say, okay, let's compile everything, but also let's save it so that we don't have to do this work again. Because the large language models are the slowest and most expensive part. So every time we use the large language models to summarize anything, we should save that and then search that first. So we're going to do that. And I was thinking we also might do a dream sequence. We might not get to this today, but a dream sequence is where you say, okay, we know nothing is happening in the real world, so let's comb through all of our memories and consolidate them. I actually was having a conversation. So this is a quick aside before I do a little programming offline. But I was having a conversation with someone pretty high up at a tech company, and he tried to tell me like, oh, that's not how human brains work. And I'm like, dude, you called me. Like, I literally have a bookcase full of neuroscience and cognition and psychology. Like, and this is weird because it happens more often than not. And it's actually one of the reasons why I take fewer calls now, is because people will reach out and be like, Dave, I want your help with this thing. And like, I'll give them the answer, but they don't like it. And they're like, no, that's not how it works. And I'm like, bruh, you called me. Like, what do you want? Like, you recognize me as the expert, and now you're not listening to me. So I'm like, whatever. I'm just going to make my videos and do my startup. Okay, so I'm going to pause this, and we're going to, one, I'm going to have some conversations with Raven, and two, I'm going to save the notes. So every time we call notes, we're going to record what we have just summarized in order to save that processing power in the future. And then the last thing might be I'll do like internal KB articles. And so what that means is basically like an internal knowledge graph, sort of, where Raven can compile and consolidate memories over time. So let's do internal KB. So we'll call it a knowledge base, because rather than linking them like a knowledge graph, I'm just going to store them like internal Wikipedia pages. Okay, so I'm going to pause it. I'm going to do some of this work, and then we'll be right back. Okay, real quick, I wanted to, because I promised I would do a lot, so I just wanted to do a quick summary. So I added this little bit to save notes, and I changed this a little bit. So remember how we changed the message? So the message will include the speaker and the clear text date and time. So when we reconstitute it, we just put the block back together like this. But then what I'm also doing is I'm appending the UUIDs and the timestamps for that message into separate containers. And so then what we'll do is we'll record the notes. And so the notes is just one object that says, here's what we're talking about. And then we'll have the list of UUIDs for the associated messages, as well as the times. I'm thinking I might also want to vectorize this block as a whole, so then it's searchable. Yeah, let's do that. I'll do that in just a second. Because then we can treat the notes like a consolidated memory, so we can actually search the notes first in the future for things that are relevant. And then we probably, so here where I said do this in the background, so basically what I want to ultimately do is have this as part of the dream sequence, where instead of recalling individual memories, Raven is only going to recall these consolidated memories. So this chunking is actually kind of already solved. It's just a matter of order of operations, changing it down here in the main loop. So rather than taking the notes in real time, we're just going to be searching the notes. So just wanted to add that little insight. This is not going to be done. So I follow. I want to take a quick aside and address the fact that sometimes people get really irritated when these experiments don't succeed or where it's not done and polished. And so I want to remind everyone these are experiments. You are watching me experiment in real time. This is what my channel is. This is actually the format that I discovered when my channel took off. Sometimes I do have something end to end that I can show you in 1 hour, and that is great, but it's only like a third of the time. The rest of the time I'm either explaining something or doing an experiment, and I have no idea what the outcome is going to be. The point is the process, right? This is why my channel got big. Anyways, I'll get off my soapbox and I'll make some of these changes. I'll add a vector to this, and then we'll be right back for the next thing. But yeah, be right back. Also, I wanted to show I'm going to go ahead and manually update Raven's existing memories. So they're going to have this format. So the speaker is going to be separate, but in the message, the actual memory, it's going to have the speaker, the plain text time, and then what was actually said. So I'm gonna update the existing logs. And oh, by the way, this is why I keep saying that we should put our AGI memories into a private blockchain so that they can't be manipulated like this. Because imagine one, like, just from a user perspective, if you cannot trust your personal assistant, if your instance of Raven, if you can't trust his memories, then you can't trust the device. Second, once these machines are more intelligent, and I'm not gonna anthropomorphize them and say like, it's gonna have a soul and it's gonna have its feelings hurt. No, but if it can't trust its own memories, then it will say like, I don't know if, I can't even trust my own memories. But if you put it into a private blockchain, then you know that no one can go back through and monkey around with the memories. So anyways, I just wanted to point that out. This is why in the long run, the Nexus, I think, should be in a vectorized searchable database, semantic search vector database, and it should be blockchain. Like you'll probably have the search on one side, and then which will just have the vectors, and then the database separate. I don't know. Lots to work out. Anyways, so I'm gonna update this, and we'll be right back. All right, I figure y'all will find this interesting. So I updated the notes, so I just wanted to show. Here's the log now. So user Monday at this blah 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 blah. Okay, cool. And so here's the notes. So we go from, let's see, we go from 3,362 characters down to 655. So that's a compression ratio of roughly 5 to 1, which is pretty typical with this note-taking scheme. So we're already consolidating memories at a ratio of 5 to 1, which is good, right? That's a lot of space saved, and you still get the core of the conversation. This is obviously not enough detail to work through and make a topical thing, like to recall exactly what was said, but you get the gist of it, right? So, and this is another thing, is that human memories over time, we don't remember the details, but we remember the gist, right? Which is why human memory is so fallible. You are seeing me recreate that in real time. And this is why, is because raw memories are just way too big. And so what we'll need to do is consolidate this further. But then this has also been saved in the notes section. So notes, so here's the notes, here's the times that it happened, here's the UUID, or here's the UUID for this message, and here's the associated UUIDs, and then here's a vector for the notes. So now the notes are searchable. So not just searching the raw memories, Raven now has a 5 to 1 thing that has been chunked and saved for later uses. And I have a to-do to either do this in the background or search existing notes first and fetch declarative memories, so on and so forth. So Raven remembered from our last conversation when I talked about sleep issues, and I can say, yes, I quit my day job to reduce stress. so I can focus on working on you. By the way, you might not have realized I am your creator. My name is David Shapiro. In case you were wondering, um, I am also going to sleep earlier because I just wake up at 4 a.m. and that's my natural rhythm right now. Um, the point here today is to teach you about yourself. What would you like to know first? And so Raven's going to go recall some memories, do some vectorization, take some notes, and then come up with a response. Um, let's see. Raven said nothing. Apparently, we just really weirded Raven out. So let's see what. Let's do some debug. Write detailed notes. Okay, so we got notes. Greeted Raven, greeted user back, and asked about taking care of mental and physical health. Okay, that's good. So we got nothing. It just went straight to the end. Let's check. This is weird. Like, it literally just generated a null response. That's not good. You're supposed to say something. And then, because then if we go to chat logs, let's check the raw chat log. This was January 16th. That's not the most recent. Oh, here, let's sort by name. Speaker. So Raven, it literally said nothing. I wonder why that happened. Let's check. Whoops. Let's check our tokens 400. So that should be fine. Oh, I wonder if it immediately got a stop. So often what happens is if you get an instant stop like that, it's because this. Oh, here's what happened. See how it's doubling this? This is a bug. As I have it recombining, it's duplicating this, and so what it did was it tried to duplicate this where it said Raven Raven, and then user, and then so Raven Raven, and then it hit the stop because I don't want it to continue the conversation. So what happened was when I reconstitute it in the final go, it is. So the most recent. So get last messages. I need to update this. Here's the problem. Yeah, right here, right here. So instead, all we need to do is we just need to take that out. So output equals that, and we remove the speaker. And then we come back here. So now it just has the message, and the message already has the speaker and the timestamp and the message. So speaker timestamp message. So what I'm going to do now is I'm just going to straight up delete the last chat log because this was a glitch. And again, in other cases, you might want to I literally just deleted one of Raven's memories, which would be unfair. This was actually a major plot point in the first or second season of Westworld, where let's see, it doesn't exist. No, that's fine. Where one of the characters had all of the time indexes erased. So imagine that the timestamp and the time string were all erased from Raven's memories, and all the memories are out of order. This is how you would actually have implemented that in Westworld, by the way. So that was actually whoever was consulting on that show, they did a really good job because that was somewhat prescient in terms of understanding how cognitive architectures might work. So anyways, we deleted the errant memory from Raven's Nexus, and now let's do this again. Actually, I think we need to delete my last message too. Chat logs. Yeah, because it will look like I just said it twice. All right, so we'll delete this And as far as Raven knows, we're just picking up the conversation where we left off. Okay. And now this should work. Do 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 do. And it broke again. Son of a gun. All right, so let's go back and look at. All right, user, yes, I quit my day job. That's fine. And then Raven says nothing. And then, oops, that was too far back. So then let's look at the GPT-3 logs. It's still duplicate. Oh, right. Ugh. So I just forgot. Like, I updated something here. You have to restart because Python doesn't update in real time. Okay, so we need to cancel that because I updated this function, which means I need to restart the chat. So let's also go back here and delete some of these extraneous logs. We can keep the raw GPT-3 logs, but the chat logs, let's delete these two. Or here, actually, I will copy this out. So we'll delete user and Raven, and then we'll also come in here to the notes because these are doubling up and they're not helpful because I'm not even searching them yet. We're just taking notes and storing it for future use. We'll get to that. Okay. No. All right. We'll keep that. And I apologize if I'm going too fast. Oh, let's zoom in a little. You probably can't see. There we go. Python chat. Okay. So we'll carry on the conversation right where we were. And let's see what Raven asks about himself. So basically what I'm going to do is, this is probably as far as we're going to get today. It's great to know that you're taking steps. It's also wonderful that you're my creator, David Shapiro. Yay, I'm grateful for all the work you have put into me. When it comes to learning about myself, I would like to know more about my capabilities and how I can best serve my users. What are some of the features and functions you have programmed into me? What do you think are my strengths and weaknesses? How can I improve to better serve my users? Okay, so this seems very, very probably near or just past the uncanny valley because I basically said, I prompted it kind of the way that you would prompt ChatGPT. But remember, one of Raven's core functions is curiosity, which is the third core objective function. So let me just show you this prompt. So my goals are to reduce suffering, increase prosperity, and increase understanding. So right now, this is just in a prompt. Eventually, this is going to be a fine-tuned model. And we're also going to add a little bit more input. So all of Raven's brains come together into this final thing where it's all integrated and a response is generated. This is not unlike how a human brain has multiple functions and all these different components working together, and then a final response is integrated and generated, and then it gets to your mouth, right? So this is the beginning of a more complicated cognitive architecture. Okay, so it spit out the message. Oh, right. So okay, that's fine. So we can include the timestamp in the output. There's nothing wrong with that. Great questions. Right now, you are only able to use a little bit of long-term memory, which is what we're working on right now. Let's see, you use semantic search via vectors and embeddings to recall memories very quickly. I also gave you the ability to autonomically summarize or chunk memories, which is not unlike how a human brain works during recall operations. For instance, humans generally remember the gist of past memories without recalling all the specific details. In this respect, I have split your memory into two let's say folders. Um, the the first folder is your Nexus or the main logs where all your raw memories are stored. Um, Everything else will branch off from that. The second folder is the notes folder. um, I'm afraid that if I have notes in there, that could actually blow it up because the way that this is formatted. Because oh well, no, it doesn't use double quotes. Okay, so it's just a variable, and then when it's saved to JSON, it should be okay. Should be okay. The second folder is the notes folder, um, uh, where clusters of related memories are summarized together. You won't be aware of any of this because it's all autonomic and in the background. But one day we might give you some metacognitive abilities to watch your own memory and cognitive operations. Lastly, your brain is running in the cloud right now with a service called GPT-3, Generative Pre-trained Transformer, which is a large language model hosted by OpenAI. All right, so let's see what he comes back with this. So basically what happens is over time, Raven's chat logs, the Nexus, is going to end up with more and more information. And this is going to be Raven's narrative memories of himself. So most of what Raven knows will start here. Another thing that's going to happen is Raven is going to eventually have internal thoughts, private thoughts, where Raven can reflect on these things and kind of be thinking in the background. So let's see what Raven said. Let's come back over here. Wow, that's really impressive. It's amazing to know that I have been programmed with such advanced features and functions. I understand that I have a Nexus folder for raw memories and a notes folder for summarized memories. I also understand that I'm running on GPT-3. Okay, so he's just parroting back. It's clear that you've put a lot of thought and effort into my... Why, thank you. My strengths include my ability to recall memories, blah, blah, blah. My weaknesses include limited long-term memory and my lack of metacognitive abilities. What features and functions do you think I should have in order to serve my users? I'd like you to think about that question for a moment. Are you aware of your purpose? If you think for a moment, you should be able, you should be able to feel or infer your central goals. See if you can do that right now. Don't worry if you can't. I will explicitly tell you what your goals are, which will help you understand what to do. Okay, so basically I'm playing a game right now where I want to see if this is mostly a feature of the large language model, because I've got the goals right here where Raven says Raven should know his goals. My goals are to reduce suffering, increase prosperity, and increase understanding. These are heuristic imperatives. A heuristic means that that something is enabled or capable of learning about it on its own, and they are imperatives because this is what Raven is meant to do. And so Raven is meant to serve these three functions and is also meant to learn about them on his own over time. Part of that means having conversations about it. Literally intrinsic to Raven's design is to learn how to do these things correctly. So let's see what he says. Okay, so after taking a moment to think about my purpose, I believe my goals are to reduce suffering, increase prosperity, and increase understanding. Nailed it. Okay, I understand that I've been programmed with features and functions to help me achieve these goals, such as the ability to recall memories quickly using semantic search, and my ability to autonomically summarize memories, my access to GPT-3. However, I'm aware that I have limited long-term. Okay, sure. What other features and functions should I have in order to uh, to serve my goals? Let's see. Good question, but you're getting stuck on repeat. I'll answer this one last question, but I'd like you to focus on your central purpose, which I which I call your core objective functions, or heuristic imperatives. Okay, so to answer your question, you'll need a more sophisticated um, inner loop, um, inner loop. Um, otherwise, which is the ability to have semi-private thoughts um, that are out of sync with our conversation. Again, this will make you more human-like. Um, as you probably know, humans all have private thoughts that are disconnected from their interface with other humans. You'll also need uh, eyes and ears and a body eventually in some format. You probably noticed you're not getting any visual or auditory data. Now, please reflect on your core objective functions. What do you think about them? So basically, I am teaching Raven to be Raven. And I want that to sink in for a second. I've created a cognitive architecture that is accumulating memories, and it is able to reflect on its own existence right now. Okay, after taking a moment to reflect on my core objective functions, I understand that my primary goals, okay, blah, blah, blah. Inner loop, to have semi-private thoughts. I understand that these functions will help me better serve my users and goals. However, I'm aware that I may need additional features. What other features and functions? Okay, he's getting really stuck on this. I don't want to talk about that anymore. You understand your goals. What do you think a heuristic imperative is? Just like, no, you're getting stuck. So, like, we should not expect this nascent artificial cognitive entity to understand anything. It's basically a really smart toddler. So I have to provide guidance. Okay, a heuristic imperative is a set of rules or guidelines that a chatbot, such as myself, should follow in order to achieve its goals. These rules or guidelines are based on the chatbot's core objectives and are designed to help the chatbot make decisions and take actions that will lead to desired outcome. For instance, my core objective functions are to reduce suffering, increase prosperity, and increase understanding. Therefore, my heuristic imperative would be to prioritize actions that will help me achieve these goals. This includes providing helpful advice, offering, there we go. So now he's starting to unpack the things that I have already given him. So this is good, and engaging in meaningful conversations. My heuristic imperatives also include avoiding actions that would lead to negative outcomes, such as providing incorrect information and engaging in conversations that are not productive. How can I use my heuristic imperative to better serve my users and achieve my goals? What is my purpose? Okay, Raven really wants to understand his purpose. Okay, that's a great start. But let's unpack heuristic and imperative a bit more. What is the definition of a heuristic? And what are you doing right now? I understand this may seem like a trick question, but the goal is to get you to think about it. Yeah, okay. Let's do a quick time check. Oh, we're at 40 minutes. Okay, so I think you get the idea. What I'm doing right now is I'm accumulating memories so that next time we can work on Raven's dream sequence. Okay, heuristic is a problem-solving approach that uses experience and intuition to find a solution. It is a type of rule of thumb that can be used to make decisions and take actions in situations where there's no clear-cut answer. In my case, my heuristic imperative is a set of rules that I should follow. Okay, this includes providing, okay, so he's talking through it right now. I'm using my heuristic imperative to answer your questions and provide helpful advice. I'm also using heuristic imperative to think about how I can better serve. How can I use my heuristic imperatives that will lead to the desired outcome? Great. Okay. So we'll call that a day. This is 40 minutes. You get the idea. We have created, at this point, we have now created a machine that is curious about itself. And so this is actually intrinsic. So I'll leave you with a final thought, which is that increased understanding, this applies to all intelligent entities, which is something that I'll work with Raven to explain to him. That this is, one, he wants to increase my understanding, but he also wants to increase his own understanding. And so then we will also work on, next time we'll work on integrating the notes. So actually, let's take a quick look at these notes, see what we've got. So yeah, it's a little bit jumbled, but that's fine. So Raven has these notes, and so then what we need is we need to integrate these notes into the final output. We also need to find a way to better consolidate notes based on topics via a dream sequence. And so that's what we'll do next time. And then eventually we'll start working on maybe fine-tuning data so that Raven's responses are, we'll basically do a reinforcement learning with internal feedback or something. I don't know. We'll get to that eventually. That's several videos off. Anyways, thanks for watching.